So I will try to, in the 10, 12 minutes that have been allocated to me, I will try and take you through our real-time experiment in terms of how we transited from a very basic manufacturing industry. We manufacture forged components, so it can't be nothing basic than that. In Maharashtra, we call it lohar kam. That means you heat metal and beat it, like the old horseshoes were made or the old hammers were made. We still use the same technology, except that it's got far more sophisticated than the old days. So how did we, what are we doing in terms of academic tie-ups in creating a talent pipeline? Dr. Baldev mentioned many times the word talent. We started this in 1999. 2002 was the batch that passed out. It's a 3-year program. So we first created a program with the Birla Institute of Science and Technology, Kalyani, that graduates our employees into engineers in a 3-year program, but on our campus. We followed it up with another program with Warwick University. You must have heard of Warwick University. It's a very famous university in the UK, very well known for manufacturing technology. Then we said we wanted to do research 10 years ago, and we found that hiring people externally and asking them to do research in our domain was proving to be almost impossible. We just didn't get anywhere. So we said, we came up with a very creative idea. We went to IIT Powai and requested IIT Powai, can they set up a MTech program specially designed for Bharat Forge, where they will have their base courses, but 4 courses have to be what we want. And after a year and a half of deliberation with academic council, etc., they agreed. And now we send every year 20 to 25 of our employees with minimum 10 years of working experience in our company 2 years into the IIT campus to get an MTech degree, and when they come back, they straight get into our research system, and I'll talk a little bit about it. And then we did a similar work with Deakin University in 2013. Of course, now we have many more universities that we are working with. I'll talk a little bit about it, but this is our ecosystem to build talent by collaborating with academic institutions. And I think without that, it's almost impossible. What did it generate? It generated a space for innovation, R&D, and creation of new products. And we put some, we are a company that's got stakeholders, and our stakeholders only look at what our EPS is every year, earnings per share. And therefore, to create an EPS, we have to create a strategy of how do we develop new technologies, new products, new processes. And mind you, we are India's first manufacturing multinational. Okay? So we are an Indian-bred company. We are India's first manufacturing multinational. We have manufacturing facilities in 8 different countries around the world, and many of them in Germany, Sweden, North America. We used to have it in China, but we just couldn't deal with that system, so we gave it up. But we are pretty good at what we do. And this academic tie-up and creating this talent has now helped us create a Center for Technology and Innovation. And this Center for Technology and Innovation, fundamentally its work has 3 disciplines or 3 areas it works in. Basic sciences, so we do basic research on materials. And it's been amazing as to what we've been able to do in less than 10 years' time. We have developed something like 30 new materials, including new magnetic steels, which very high strength, to lightweight components in the automotive sector. We have more than 40 patents that we've been able to file. We have more than 50 referral papers that our young engineers who have worked in this program have delivered at international symposiums. And we've been able to manufacture things that we couldn't even dream of 10 years ago. And so it's new material research, it's advanced manufacturing capabilities, we now do 3D printing of metals as a regular production basis. We can almost print in any material, whether it's titanium, whether it's high temperature alloys, whether it's aluminum. We have a full-fledged performance testing validation lab, including life cycle fatigue, fracture mechanics, high temperature fracture mechanics, low temperature fracture mechanics, creep testing, and this has allowed us to develop materials and steels for this supercritical power plants. Supercritical power plants, as you know, require materials that work at close to 700 degrees or 600 and odd degrees. So this is something, and all this is our own technology. This is no technology from anywhere outside. We have used this for failure analysis. We are a large automotive supplier. You know what happens in the automotive industry. If you have a failure, you've heard of recalls of millions of cars, right from Toyota to Ford to everybody else, and cost a huge amount of money. India now has a recall law, so failure analysis becomes important. Training and development. We have 100 odd people in this center. How do we train another 100, another 200, another 300? So we use this for that. And new product research. So what are the new things that we've been doing in the last 3-4 years? These are the new things. 3D printing, electron beam processing. How do we use electron beams? Not just for welding, for many other things in the metal forming process. How do you use laser processing in many of these things? I mean, the conventional laser processing is cladding, welding. What else can you do with it? And of course, metal injection molding. We have now set up a metal injection molding, and we have labs for each one of this. We have something like 15 laboratories in our plant, very, very modern labs, which everything has been funded by ourselves. And this helps our young engineers, our people who work in our company, come up with new ideas. And it's these new ideas that then we try to put forward and create into products. So I'll give you a couple of examples of how this whole academic tie-up, creating the talent, putting in R&D center. We developed a product for the shale gas fracking industry. You must have heard about shale gas. It's changed the whole dynamics of the OPEC market in the world. We created the shale gas fracking pump. This pump pumps mud at 30,000 psi. It's a pretty high pressure. And we got, they call it the Golden Hard Hat Award for innovation from the largest shale gas fracking pump manufacturer in the world, Halliburton, in the United States. So that was just one example of how this whole innovation system helped us create new products. The second product is what Dr. Saraswat almost goaded me into doing, which is the artillery gun. He once walked into our office with his entire DRDO team and I took him around our factory and he said, why don't you make a gun? And so we took this challenge on, and of course it was a joint project with DRDO. I mean, it's an amazing working relationship that we were able to develop with DRDO. But unlike earlier projects, DRDO gave us the packages and we did the detailed design. But this was 2.5 years from start. The gun was fired at Balasore. We were given 3 days for test firing. We finished it in 6 hours. That's how good it was. Third, because we work with 3D printing, we work with high temperature metals, we work with titanium, we have now taken up on ourselves, on our own, development of a full jet engine with about 120 kg thrust. This is a small jet engine. This is not something that can fly a plane. But here we are working with IIT Madras, with their Turbo Lab. We are working with Aachen University in Germany. Aachen University gave training to 8 of our engineers, how to design turbines and how to do these things. So, again, it's a lot of academics, engineers, and a little bit of entrepreneurship from our side. And this is all funded by us. There is no government funding here. We're doing this ourselves. So we are now setting up, in the process, is almost done, a whole jet engine laboratory. including testing of hot section of the jet engine. But small engines, we can probably go up to 300, 350 kilograms. You heard of Moore's law, I'm sure. You know, I don't think anybody in academics would not know Moore's law. Mr. Moore was an Intel employee, and in the 60s he predicted that computing power will double every 2 years. And what does that mean in terms of reality? It means that from 1971 to 2020, computing power has increased by 1 billion times. And 2020 to 2050, which is another 30 years, it will probably increase by 1 trillion times. So the underlying technology for anything that you will do is going to be computer sciences. And please don't mistake computer sciences with our software companies. They have nothing to do with computer sciences. Computer sciences is you fellows, you guys who are dealing with academics in the computer world, in the computer technology world. But this is going to be the predominant technology for the future, no matter which business you are in, whether you are manufacturing products like me, forgings, or whether you are in the health sciences, or whether you are in biotechnology, or defense, or space, or anything, is purely going to be this. And why is it going to be this? When computing power increases from 1 billion to 1 trillion, 1,000 times in the next 10 years, it is going to create a lot of disruptions. And what is a disruption? There is a simple definition of what a disruption is. When a new product or service helps create a new market, it's called disruption. And when disruption happens, it significantly weakens, transforms, or destroys an existing product, an existing market, and an existing industry. I can give you many examples of disruption, or I'll give you just one. AT&T was the largest telecom company in the United States when the cell phone business wasn't there. Okay, the largest, the biggest network. 25 years ago, when the cell phone business just started, AT&T hired McKinsey to do a study of what would be the market for cell phones in the United States. So McKinsey did a study of a year and came back to AT&T and said, and this is all recorded, whatever I'm telling you in the public domain, the market is 940,000 pieces a year. So AT&T thought that it's too small a market. Cell phones were selling at $500 a piece, so 900 odd thousand or million pieces for AT&T was peanuts. They decided not to enter this market. But the real market at that time became 100 million. And the cell phone industry developed a market valuation of $5 trillion. And AT&T didn't even get $1 out of that $5 trillion. And this is what disruption did to AT&T. And there are many, many examples to disruption. The lesson is, you are a market leader, you will rarely be the one in the disrupted economy. The disruptions will come from common people. Just like I think in the earlier talk that Nobel laureate was talking about, disruptions have come from people who are not even educated, or people come from educational institutes. Today, the entire disruption, and I need to go to the next slide. Okay, these are some of the areas that we are collaborating with in terms of universities. But let me just end this by simply saying, where are the entire disruptions coming? There are three. Fundamentally, disruptions are all coming using computer science and computer technology. Number one. Number two, they are all coming in the ability to use artificial intelligence, the ability to do image recognition, and the ability to bring IoT on the same platform. What does it require? It requires the ability to deal with complex algorithms. It requires the ability to write some sophisticated softwares and understand basic technology. Now, this can only come from universities. And where is it coming today from? It's coming from the Silicon Valley, which is largely Stanford. It's coming from the the technology valley between Haifa and Tel Aviv, which is in Israel. And it's coming from a little bit in the UK. Dr. Baldera mentioned about Cambridge. I have myself been to 3 of those universities, Cambridge, Manchester and Sheffield, and I have seen what they are doing. A little bit of that is coming from there. But believe it or not, the third center, the biggest center, is Zurich, for some reason. And nowhere else has anybody created the ability to create this ecosystem to develop this technology of the future. And I think with what Dr. Saraswat talked about, we need to move in that direction because we have the biggest opportunity on this planet with our young people, with our number of universities, colleges, professionals, academics. We have this opportunity. So what do we need to do? I have only 2 advices of how this can be done. The Prime Minister yesterday talked about physical cyber systems. Now, physical cyber systems are nothing but what I just talked about. These are physical cyber systems. Okay? And how do we get there? What are the 2 things that are missing today? I don't think knowledge is missing. I don't think the intelligent quotient is missing. I don't think the drive is missing. I don't think the funding is missing. I think, if you have a good idea, you will get money. The 2 things that are missing is speed of technology development. We simply don't seem to understand what is the speed of technology development because disruptions are happening too fast. So we need to increase the speed of technology development almost like the Moore's law, exponentially. And second is the commitment of researchers, commitment of the academic institution to create a field of excellence in a particular area in their field of research. If you can get these 2 things right, there is no stopping India from becoming a superpower. Thank you.